Hello and welcome to Intimate Algorithm. So in this tutorial we'll be looking at queue, which is one of the important topic in data structure and algorithm. So it is just one way to arrange the data or to store the data uh, in the memory. So actually queue, it follows FIFO principle. It means first in, first out principle. So in the course of inserting and deleting the data which we have inserted first will be deleted first. And here we are not talking about the priority queue, just a normal queue. Like the queue in ticket counter, the person uh, which goes to the counter first will receive the ticket first, and the person who will go to the ticket counter at last will receive the ticket at last. So there is no priority, just the first come first serve principle. And here we can apply the concept of queue either using the stack, which is static, and we can also implement a queue by using linked list concept, and this is dynamic. Dynamic in a sense that it is never full. I mean, we can insert the data, as many data as we want, so the memory location will be allocated dynamically in this case. So but in case of static implementation of queue, first of all we have to allocate certain memory location. For example, if I allocate memory location 5 as in this case, so our memory location has started from 0, 1, 2, 3 and 4, and this is contiguous memory allocation. And after we have inserted 2, 4, 6, 8, 10, these are our random data I've inserted here. So after inserting 5 data, our queue will be full, so we cannot add any more data inside the queue if our queue is full. So but we can delete the item from the front. So this is the front. So if I delete, 2 will be removed and 4 will move here, 6 will move here, 8 comes here, 10 comes here. So there is shifting of data towards the left. This will occur when we delete any item from our queue, because the position that was held by the first member will be now occupied by the second member in the queue, and so on. And one more thing, for during the queue implementation, we make the use of variable front and rear to indicate the position where the queue had started and where the last item is in the queue. So it is pointed by rear variable, and the starting position is always 0, and it is pointed by our front variable. Now let us talk about the program on how to insert and delete the data in our queue. But before that, let me allocate some memory location. Here we are going to implement queue statically, sorry, not dynamically. And for that, let me write here define, and I'm going to write a variable name size, and let me say the size is 5. So this we're going to write at the top where we declare our header file in C programming. And initially both rear and front variable are pointing to memory location 0. So let me declare these two memory location, and these are of type integer. So int rear is equal to 0, and at the same time I'm going to declare int front is also equal to 0. So both rear and front are pointing to 0 at first, and this means that our queue is empty. So when rear and front are both equal to 0, this indicates that our queue is empty. Now let me talk about the insert function. So I'm going to declare it is of type void. I'll give the name insert, and the data I want to insert is, for example, say data. And for inserting, what I have to check is whether our queue is full or not. So if our queue is already full, then we can no longer insert the data in our queue. So this will occur, for example, say our data is 2, 4, 6, 8, 10. So now our rear, as 10 is our last data, and I've already told you that we insert the data at the rear. So now rear will be pointing at memory location 4, but after inserting every time we insert the data, we are going to increase the rear by 1. So after inserting the data at 4, rear will be pointing at memory location 5 right over here. And I'm going to erase this rear. Now when our rear is equal to 5, and we've also defined our size of queue to be 5, when rear is equal to size, this indicates that our queue is full. So here I'm going to check if rear is equal to size, then we can just print the message saying our queue is full. Else, if our queue is not full, so I'm going to write here the condition for else what we can do is, so let me first declare our queue. So it is of type int, and I'll just name it queue and give it the size, which is size. So in place of queue, and then queue of rear, as we're going to insert our element in rear. Now at first, when the queue is empty, so here rear is pointing to memory location 0. So in queue of 0, in queue of rear, we are going to insert our data, which is data, and after that, now real will be pointing to rear memory location 1. So we just have to increment rear by 1. So I'm going to write rear plus plus. Say the data we have inserted here is 2. So here we'll write 2, and for second case, what we're going to do is we're going to check the condition once again. If rear is equal to size, so here rear is equal to 1, which is not equal to size, so our if condition will fail and we have to move on with else condition. So for else condition, queue of rear, so queue of 1, and as rear is pointing to memory location 1, so in queue of 1 we're going to insert our second data, say 4, and after that we're going to increment queue by 1 once again, so rear will be pointing to 3, and this will go on till our rear will be pointing to memory location 5 right here. So for for third data 6, rear will increase to 3. For fourth data 8, rear will be increased to 4. So I'll insert another data, last data, and again we will increase rear. Now rear will be pointing to 5, and then we can add no more data. So our if condition will execute as rear is equal to size, which is equal to 5, and just we can give the message to the end user saying that the queue is full. So I hope you got the concept for how to insert the data, and this is all for this presentation. I'll be talking about how to delete the item in my next presentation. So thanks for watching.